Again, welcome to DSRT 734 class, Inferential Statistics in Decision Making. These lectures cover probability rules. Probability law 1. Probability of 0 means the event cannot happen. For example, the probability of observing 3 heads in 2 tosses of a coin is 0. Probability law 2. A probability of 1 means the event must happen. For example, if we toss a coin, the probability of getting either head or tail is 1. So probability of 1 means the event must happen. Probability of 0 means the event cannot happen. Now, law number 3, all probabilities must be between 0 and 1 inclusively, which means include 0 and 1. The closer the probability is to 1, the more likely the event. The closer the probability is to 0, the less likely the event. So for an event A, this is expressed as following. Probability of A can be less than or equal to 1 or greater than or equal to 0. So all probability values must be between 0 and 1 inclusively. Probability law number 4. The sum of the probability of all outcomes must equal to 1. Again, the sum of the probabilities of all outcomes must equal to 1. That is, if probability of A is the probability of event AI and there are n such outcomes, then we say probability of A1 plus probability of A2 plus probability of A3 up to AN is equal to 1, which means the sum of all the probabilities of the outcome must equal to 1. Next, we go to the compound event. A compound event is an event that is defined by combining 2 or more events. And what is a union? A union of event A and B is the set of outcomes that included in an event A or event B or both. Normally, we use the symbol U. So the union of A and B is denoted at AUB and is read at A union B. So the union of event A and B is the set of all the outcomes that is included in both event A and B. And so example of a union using the Venn diagram, everything within A and B circle. So event A is red circle, event B is blue circle. So the union of event A and B is everything on A and B. Intersection. Intersection of event A and B is the set of all the outcome that is included in both A and B. So now the union of event A and B is all the outcome in A and B and both. But intersection is the outcome that is included in only both A and B. So symbolically, we have the symbol A intersect B. So the Venn diagram, we can see the shaded area is the intersection of A and B, which means at this shaded area is where event A and B occur at the same time. So intersection is only the outcome where both event A and B occur at the same time. Union is everything of A and B, including the intersection of A and B. We have complement. A complement of an event A is the set of all outcomes in the sample space that are not in A. So we use the symbol A to the power C. So this example, a complement of A means everything that is not in A. So we are assuming all the area here is the sample space, the total, or we say the universal set when we deal with set. Or here we say the total outcome, the sample space. So the complement of A is everything that is not in A. Then we have a probability law 5, that's the complement of an event. So the probability of A complement is given as A minus probability of A. Since the probability of A, the complement of probability of A means all the outcome that is not in A. So the all will be the total of 1. So the probability of A complement will be 1 minus probability of A. So we remove everything from A and the rest will be the complement of A. So let's see example. Here they say we should consider the event A. The event A is annual income is greater than 50,000. Suppose the probability of A is 0.08. We should determine the probability of observing someone whose income is less than or equal to 50,000. So the solution will be probability of annual income that is less than or equal to 50,000 is equal to probability of A complement. Here we say probability of A means the annual income is greater than 50,000. So the probability of A complement will be annual income is less than or equal to 50,000, because the complement of A means everything that is not in A. Since A is greater than A is greater than 50,000, the complement of A will be anything less than 50,000 or equal to 50,000. So that will give us 1 minus probability of A. And we know the probability of A is 0.08 is given to us. So the probability of A complement will be 1 minus 0.08, which will give us 0.92. Again, this question said we should consider the event A, which is annual income is greater than 50,000. Now, the probability of annual income is greater than 50,000 is given to us at 0.08. What is the probability of observing someone whose income is less than or equal to 50,000? So that will be the complement of A. So it will be 1 minus 0.08, and that gives us 0.92. Next example, we're going to consider an experiment to see how many tosses of a coin will be required to obtain the first head. The first head could be observed on the first toss or the second toss, but there's no upper limit on the number of tosses that could be required. Therefore, the sample space for this experiment is a set of positive integers. There's no upper limit. Now, not only is the sample space infinitely large, but there's another problem. The outcomes are not equally likely. So this is a potentially ugly environment in which to compute a probability. But let's make matters slightly worse. Suppose we want to know the probability that it will require at least 2 tosses, that is 2 or more tosses, to get the first head. This means that we must compute the probability of 2 tosses before the first head appears, the probability of 3 tosses to get the first head, and so on up to the infinity, and add them in some way. Now, the problem is rather insidious if approached directly. Now, this is the solution. The problem becomes rather trivial by determining the complement of the event and computing its probability. We need to know the complement of the event, then we can find it. Now, the complement of obtaining the first head in 2 or more tosses is getting a head on the first toss. The probability of getting a head on the first toss is 0.5, assuming the coin is fair. Therefore, we have the following. Again, the coin have only 2 outcomes, head or tail. So the probability of getting head is 0.5. Probability of getting a tail also is 0.5. So here we say probability of 2 or more tosses to obtain the first head will equal to 1 minus probability of head on the first toss. So we get 1 minus 0.05, and our answer will be 0.5. Next, we go to what the meaning of odds. Odds in favor of an event A occurring is given by following. Probability, this is odds that favor A. So it will be probability of A divided by probability of not A, which is the complement of A. Now, the odds that go against an event A will be probability of not A divided by probability of A, which is probability of A complement divided by probability of A. So let's see example. In the game of American roulette, the roulette wheel contains the numbers 1 through 36, alternating between red and black. There are two green spaces numbered 0 and 00. First, we should calculate the probability of the roulette ball landing on a red pocket. So the solution will be, since we have again 18 red pockets and 38 possible pockets on which to land, then the probability of landing on red is given by following 18 divided by 38, which will give us point something. Now the second is calculate the probability. Again, let's go back again. Now, when we look at the question, we have 38 possible. The reason why it's 38, we can see the number is 1 through 36, but also we have two green spaces, 0 and 00, so that total is 38. Now, since total red is 18, then it will be 18 divided by 38, which is roughly somewhere around 0.18. Now, the second B said, calculate the probability of the roulette ball not landing on the red pocket. So in this case, the same concept of probability of not landing on the red pocket is found by 1 minus 18 over 38. Since I know the probability of landing on the red, I'm going to subtract it from 1 and I will get not red. So it's complement. So that gives us 20 over 38. Now C, calculate the odds in favor of the roulette ball landing on red. So in favor means the probability of landing on the roulette ball on red divided by probability of not landing. So that will give us the odds in favor of roulette ball landing on red is probability of red divided by probability of not red. So we know probability of red was the first 18 by 38. Then not red was the second, which is 20 over 38. And that will give us roughly 18 by 20. And that will be 9 to 10. Again, the odds in favor of roulette ball landing on red will be probability of red divided by probability not red. Now, the odds in favor of the green spaces, in this case, we know the green spaces is 2. So probability of green spaces will be 2 over 38, then divided by probability of not green again face. So next is the mutual exclusive. We say two events are mutually exclusive if they have no outcomes in common, which means the two events cannot happen at the same time. So here we have event A and B. We consider there's no intersection, which means event A and B cannot occur at the same time, cannot. Then this will tell us that if event A and B are mutually exclusive, then the union, probability of A union B, will be probability of A plus probability of B. Now, if the events A and B are mutually exclusive, then probability of A intersect B will be 0, because if A and B are mutually exclusive, it means they cannot happen at the same time. So the intersection of A and B will be 0. Now, suppose that the probability of A is 0.27 and the probability of B is 0.19. If A and B are mutually exclusive, what is the probability of A union B? So we add them together since they are mutually exclusive. So our solution will be probability of A union B will give us probability of A plus probability of B. And that will give us 0.27 plus 0.19. And it will give us 0.46. Next, the general addition rule. The general addition rule normally is when we have two events that are not mutually exclusive, which means both events can happen at the same time. In this case, probability of A union B will be probability of A plus probability of B minus probability of A intersect B. We say if two events are mutually exclusive, the probability of A intersect B will be 0. So that's why we don't use it. When they are mutually exclusive, we don't say minus probability of A intersect B. Now, if it's mutually exclusive, it means both events can occur at the same time also. Now, let's see an example here. Suppose that a marketing manager believes that the probability that someone earns more than 50,000 is 0.2, and the probability that someone will subscribe to more than one sports magazine is 0.3. If the probability of finding someone in both categories is 0.08, what is the probability of finding someone who is earning over 50,000 or subscribe to more than one sports magazine? So here we can see it's all, so it will be union. So probability of the problem involving union of two events using the event A and B. So probability of A union B will give us probability of A plus probability of B minus probability of A intersect B. So we know probability of A will be 0.2, and based on the question, we can say that if we earn 50,000 is probability of A 0.2. If we subscribe for magazines, probability of 0.3. Now, if both is 0.08, so it will be 0.2 plus 0.3 minus 0.08, and that will give us 0.42. Therefore, the probability of finding someone who is earning over $50,000 or subscribe to more than one sports magazine or both is 0.42. Okay, so this will be the conclusion of our lectures. In these lectures, again, we go through the basic probability laws, and also we went through the union, intersection, and also complement. Thank you very much, and see you in the next lectures.